So in this session, I'll discuss the doubts related to projectile motion. So instead of discussing a specific part, we'll discuss like the full question. So the first one, question 20. Question 20, the monkey and the hunter is a thought experiment to illustrate the independence of horizontal and vertical motion. Like this is an experiment which shows the horizontal and the vertical motion are independent of each other. Like this ball which is launched horizontally initially, the horizontal speed does not affect the time it will take to hit the ground. So we have to show that it's independent. So a student modeled an experiment by projecting a table tennis ball at the toy monkey. The ball and the monkey initially at the same height of 0.25. The monkey drops at instant and the ball is projected. The monkey and the ball will meet irrespective of their horizontal separation. Hence, if when we launch this ball horizontally, the ball will have two component of motion. Initially, there is only horizontal, but then it will have horizontal and vertical. And every moment, like the horizontal positions, the vertical position mainly, that will be same. Like the vertical position of the ball will be same as the vertical position of the monkey. Show that the time taken for the ball to fall to a bench is about 0.2 seconds. So we have the height from which it is dropped. So the height is known, the distance is known. There's a horizontal velocity, but the vertical velocity is zero. Horizontal velocity will have some value, but the vertical component is zero. So we can use the formula equation of the motion whenever we use a vertical motion. So S is equals to ut plus half at square. For falling objects, the vertical component is zero. So this whole factor will be zero. So we can say that S is equals to 1/2 and acceleration is due to gravity and time t square. Why? Because the initial velocity is zero. When we substitute the values, here, the height from which it is dropped, that is equals to 0.25. The acceleration due to gravity, that's equals to 9.81 and time is t square. We have to show it take about 0.2 seconds. So 2 is divided, other side it will be multiplied. So it will be 0.25 multiplied by 2 divided by 9.81. That's equal to t square. But we need t, so we have to take root both sides. When we take under root or square root both sides, that will give us the value of the t, which is about, because we have to show it's about 0.2 seconds. So when we simplify this will give us 0.23. So 0.23 second is the time taken by this ball to drop a distance of 0.25 meter. The ball is projected horizontally at a speed of 2.6. Calculate the horizontal distance. So the launching speed is 2.6 meter per second. And the time it takes to fall, that's equals to 0.23 second, that we already calculated the first part. We want to calculate the horizontal distance or the range of this projectile. How to get the range? Range is a distance. that is speed, because speed is distance divided by time. So distance is speed multiplied by time. So simply, whenever horizontal components are used, we don't use equation of the motion, as there is no acceleration. We assume there is no air resistance to oppose the motion. So speed equals distance divided by time. The launching speed is 2.6. The distance is what we are finding. We can also say the range. And the time it took, that is 0.23 seconds. So 0.23 is divided. Other side, it will be multiplied. So when we multiply this 2.6 into 0.23, this will be about 0.6 meter. 0.6 meter is a range, the horizontal distance which is covered by this projectile. The variation, a variation of this experiment is where the monkey is initially at a higher speed so that the ball has to project it upward towards the monkey. The two objects will still always meet. So complete the diagram to show the path of the ball and the path of the monkey. Because the monkey, it's having only one component, that is a vertical component, it is falling. So the path of the monkey will be a vertical motion. But what about the path of this tennis ball, that as it is launched, so the trajectory or the path, it will be a parabolic curve. And they mentioned they both will meet. So they will meet at this. Why? Because this is having both component horizontal and vertical. But for monkey, as it is falling vertically, there is no horizontal component, only vertical component. Yeah, that's a good question. The question is why, why we did not draw a path or a trajectory like this. We draw the monkey and then the ball is still rising. Why we did not sketch such path? Such path is not acceptable. It is wrong. What is the reason for that? Because the trajectory, the launching speed, even like if you sketch here, the we have to show curve path. It's not like um, it's you can, even if you draw like this, that a monkey is falling and you draw a trajectory in this manner, that is also acceptable. This is not wrong. But you cannot draw that a ball is rising and the monkey is falling. So this is not acceptable. This is acceptable. It's not like when the monkey is on the ground and the ball will hit the monkey. You can draw this path as well. This is acceptable, that both are in the air and they beat each other. Any path acceptable, but not the path in which the ball actually directed towards the monkey and it hits the monkey. That path is not acceptable. Is it clear, this part? So only path which is rejected is the ball is directed towards the monkey and you show that the ball hit the monkey. That is rejected. But if you draw the ball is rising still and hits the monkey, this is acceptable as well. Or ball is coming down, trajectory, because the angle of inclination is so small, so likely the ball will return back. So this path is also acceptable. Or it returned back to the ground. This path is acceptable, but not direct. The ball is projected with a velocity of 3 meters per second at an angle of 20. If the monkey is at horizontal distance of zero point 0.5 meter, will how far will it how far will it have fallen when it meets the ball? Now this part is related to calculation, so we have to calculate. So when we launch this ball is launched at an angle of 20 to the horizontal. I can take the axis here, I can take the axis here. That does not make difference. So ball is launched at a speed of 3 meters per second. With a launching angle of 20. First thing, whenever you solve a question, such question, you will always resolve the velocity into its component, the horizontal and the horizontal component, which is written with cosine. So that will be 3 cosine 20 here. In this case, because the angle with x-axis is given. And the vertical component, you will take as 3 sine 20. And the distance between the monkey and the ball, that is 0.5 meter. Like this distance is equals to 0.5 meter. So we have the distance and we have the horizontal speed. So using the distance and the horizontal speed, we will find how much time it will take to hit or cover this 0.5 meter. That is the first step. So we have, and whenever we are using the horizontal speed, so speed equals the distance divided by time. So speed, because in a horizontal motion, horizontal component, there's no acceleration. So we always use this formula. If we take a vertical component, we have to use equation of the motion. So speed is equals to 3 cos 20. The distance is equals to 0.5 and time we don't. So we cross multiply. That's equal to 0.5 divided by 3 cosine 20. So this will give us the time it will take to cover this 0.5 meter, which is about 0.177 seconds. So this gives us the time it will take to cover this 0.5 meter. Now, the second part, because that is the main part, they ask, as a ball is projected with a velocity of 3 meters per second at an angle of 20, if the monkey is at a horizontal distance of how far will it have fallen when it meets the ball? Now, the ball is taking 0.177 seconds. So if the ball is taking 0.177 seconds, so that now we will find how much distance the monkey has covered in this time. Because when the ball covered 0.5 meter, the monkey is falling. So they meet at this point. So when they meet, it means the time taken by the ball to cover 0.5 meter and time taken by monkey to fall, that is same. So that is equals to 0.177 second. Now we'll only consider like the distance covered by the monkey. As a monkey is falling objects, the initial velocity is always zero. The time we have, which is 0.177 seconds. We want to find how much distance it covered or the height, so we can use equation of motion. And for falling object, the acceleration is due to gravity. So S is equals to ut plus half at square. But because this object initial velocity is 0, so this whole factor will be 0. And we'll have 1 by, this whole factor will be 0. So we'll have 1 by 2 gt square. And it will be half. The gravity is 9.81 and the time it took, that is 0.177 seconds square. So when we simplify this, this will give us the distance which is covered, the vertical distance which is covered by the monkey. It is equals to 0.154 meters. Like that is a distance which is covered by the monkey. Then next is question 21. Instead of discussing a specific part from the question, I'll discuss the whole question. In area for where the planes are unable to land, free fall airdrops can be used to deliver the supplies. A plane traveling at a speed of 75 meters per second. So the moment it drops the package, that will also have the same speed because that was there. So the speed of the airplane, if it is 75, the speed of the package will also be 75 meters because that is delivered by the aircraft. So they have the same horizontal speed. Then as a plane will continue, but what will be the trajectory or the path of the airdrop? That will be projectile. Draw the path of a falling package and show that the time for the supply is about 4 seconds. How we can show that the time it takes is about 4 seconds? We have the height that it is released from 63 meters. We have the horizontal speed. But what about the vertical speed? The vertical speed will be 0. Because the package initially, whenever a projectile is launched from certain height, it is having initial vertical velocity 0 and all the velocity is the horizontal. So we can simply use, and it's a falling object, so expression is due to gravity. So we'll use S is equals to ut plus half at square. Again, the initial velocity is 0. So if initial velocity is 0, this whole factor will be 0. Then it will be S is equals to half gt square. S is a vertical height, vertical displacement, which is 63. Half expression is due to gravity 9.81 and times t square. So we simplify 63 multiplied by 2 divided by 9.81 is equals to t square. We take under root, square root both sides. This will give us how much time this package will take to hit the ground. And this will be about 4. It's not like you get exactly 4. It's just closer to 4. That is 3.6 seconds it will take to hit the ground. The next part, calculate the horizontal distance of plane from the drop zone when it releases the package. So basically, we have to calculate the horizontal, as we assume practically, the horizontal component does not remain same. Practically, it will change. But as to solve a question, we always assume the horizontal component is same. So means the horizontal component, which is 75 meter per second, it remains 75 meter per second throughout. So the distance, the horizontal distance covered by the package is same as the distance covered by the plane from the dropping point. So we have to calculate this range here. How to calculate the range? We have the formula speed is distance divided by time. Speed is 75, distance we don't know, and the time we calculated the package will take 3.6 seconds to hit the ground. 3.6 is divided, other side it will be multiplied. So when 3.6 is multiplied by 75, that is equals to 270 meters. So the horizontal distance will be about 270 meters, or the distance covered by the plane is also 270 meters because the plane is also moving with the same horizontal speed as a package. But as I mentioned, practically it won't be same, but theoretically, as we assume that there's no air resistance, then it will be same. Then question 22. Skateboarder throw a ball vertically up while traveling at a constant horizontal speed. The skateboarder catches the ball the moment later, still moving horizontally. Explain why the ball can be caught even though it was thrown vertically upward and the skateboarder is moving horizontally. Ignore any effect of gravity. First, what will happen, because this ball is being thrown by the skateboarder. So skateboarder is only having the horizontal component of the velocity. But when he throw the ball will have two components. One is the horizontal, and the horizontal component of the ball, because he throw the ball, the horizontal component of the ball is same as the horizontal component of the skateboard. So means horizontal distance will always be like if a ball cover horizontally say 1 meter, the skateboarder will also cover 1 meter. If horizontally the ball cover 2 meter, skateboarder will also cover 2 meter. If horizontally 3 meter, this will also be three. If horizontally 4 meter, this will also be four. So horizontal distance will always be same for both. Like ball will always remain above the skateboarder, like, because they have the same horizontal. Vertical components will be different. Like when he launched initially, the vertical component will be, this vertical component will be the maximum in the beginning, but as the ball is rising, the vertical components start to decrease, and the maximum height, the vertical component is zero, and then it start to increase again. And the horizontal and vertical components are independent of each other. So these horizontal components are not affected by, so if I say that this was 2 meter per second, so all the places the horizontal component of a velocity is 2 meter per second for the ball. So as it is 2 meter per second, the ball will cover the same horizontal distance. So the ball will always remain at the top of this skateboarder. So the points which you should mention: first, 1 mark you will always get when you mention the horizontal and vertical components are independent of each other, does not depend on each other. The second mark, the horizontal component, the horizontal component of the ball is same as the horizontal component of the, or horizontal velocity of the skateboarder. Then the ball will always, because they have the same horizontal speed, so ball will always cover the same distance as a skateboarder horizontal distance, or the ball will always remain at the top of a skateboard at any point. And what about the vertical motion? It will accelerate, it will decelerate when it is going up, like the vertical component decreases. And then when it is coming down, the vertical component will increase. So this was question 22, then question 24. In question 24, the gravitational field strength of the moon is about 1/6 of the gravitational field strength of the Earth. On the moon, the astronaut dropped a golf ball. He later wrote, "When I dropped the ball, it took about 3 seconds to land." So that the astronaut would need to be over 7 meter, like tall, for a ball to take 3 seconds. So it's up to you. Either you can work out, like you take a distance and you find the time, or you have the time, you find the distance. Because the answer is given, but we have to consider one as unknown. Like to work out if a ball is dropped from a height of 7 meters. So example, if we say we drop, or we know the time it's taking 3 seconds. So whenever object is dropped from certain heights, its initial velocity is always zero. And it will have acceleration due to gravity, which is 9.81 meter per second square. So how much time it will, and say, if we say it is taking 3 seconds to land, so what distance it from which distance it is dropped. So we'll use equation of motion S is equals to ut plus half et square. So this is a very common equation and mainly for falling objects or objects which are launched upward or a projectile, we normally use the initial velocity is zero. The initial velocity is zero, so it will be S is equals to half gt square. Then it will be half, gravity is 9.81 and time that is 3 that square. So when we simplify, this will give us about 7.4 meters. So it's like it should be over 7 meters. So that is true. Like the statement is true if a ball is taking 3 seconds. But one small mistake here, like the gravity, because as I mentioned, it is drop on the moon, not on the earth. So I should divide by 6, like 1/6 of so this should be the gravity of the moon is about 1.66 meter per second square or 9.8 divided by 6. So I'll get a 7.4 meter. If it was on Earth, I should take 9.81, but as it is on Moon, so it should be 9.81 divided by 6 or 1.66 meter per second. Astronaut hits the ball with a golf club. He wrote the ball, which would have gone 30 to 40 yards on Earth, went over 200 yards on the surface of the moon. The ball stayed up in a black sky for almost 30 seconds. Like that's the total time of the flight. Assume that the initial velocity of the ball is 18 and angle from horizontal is 34. Show that the astronaut suggested time for a flight of 30 seconds is over twice the actual value. So as the astronaut is saying, it's like the ball would have gone 30 to 40 yards, and on Earth now it's on Moon, so it is traveling about 200 yards, and the ball is staying there in air for 30 seconds. So we have to show the time of the flight of 30 seconds is over twice the actual value. So first, whenever you have a question in which object is launched with a certain height, you will always resolve into components. So an object is there launched at a speed of 18 meter per second and making an angle 34. So there will be two components, horizontal and vertical. The horizontal component is with cosine, so it will be 18 cosine 34. And the vertical component will be 18 sine 34. These are the two components, horizontal and vertical. First, we will find the time it will take to reach the maximum height, and the total time will be twice of it. So, but in this case, because we are fine, and it will have a deceleration or acceleration due to the gravity, and that is about, because it's on moon, so 1.66 meter per second square, and negative. The gravity of the moon is 1.67 Newton per kilogram. So first we'll find the time it will take to reach the maximum height. So we have the formula V is equals to U plus AT. Final vertical speed is 0. Horizontal will always be same, like it will be 18 cosine 34. Vertical is 0. Initial vertical is 18 sine, because it's a vertical motion. So 18 sine 34. Why minus? Because it is decelerating, so minus 1.66, that gravity expression due to gravity. And time we are finding. So we simplify, like this will move other side and 1.66 will be divided. So it will be 18 sine 34 divided by 1.66. That is giving us the time. So time to reach the maximum height is 6.2 seconds. So if the maximum height, it took 6.2 seconds, so how much time it will take to return back? Same 6.2 seconds. So what will be the total time of the flight? The total time of the flight will be 12.4 seconds. So that is so as you can see, we have to show that the suggested time of a flight of 30 seconds is over the twice of actual, like more than the double of actual value. Actually, it will take 12.4, but 30 seconds is more than double of actual value. So it will take about 12.4 seconds to land on the surface of the moon back again. The next part, show that the value given for initial velocity leads to a value for the horizontal distance traveled by the ball agreement with the stated value. So because it's mentioned like the ball will cover 200 yards on the moon. Like this total distance will be about 200 yards, which is about 130 meters. So we have the horizontal speed, we have the total time, it is 12.4. So we can find the distance. Speed is distance divided by time, distance speed multiplied by time. Horizontal, because there is no acceleration, so we always take, we don't use equation of the motion. We always use speed is distance over time as it is not accelerating. So what is the launching speed? We have to take the horizontal speed, which is 18 cosine 20. And the time, that's the total time for the flight, which is 12.4, like how much time it will remain in it. So when we multiply, it's about 185 meter. 185 meters approximate, like 180, it's like over 200 yards because 183 meters, 200 yards. So if it is 185 meters, it means it is more than 200 yards. Then a projectile would have a greater range on the moon than Earth because of a lower gravitational field strength and because of a lack of atmosphere. Explain how each of the factor would increase the range of a projectile. So first, when it is having a lower gravitational field, so the acceleration, it will have a smaller acceleration. So the time of the flight, because if time increase, the range will also increase, the vertical height will also increase. So a smaller value of a g means it will take more time. If it take more time because range is speed multiplied by time, so if speed remains the same but time is increased, so range will also increase. The second one, as there's lack of atmosphere, there's no air resistance. So this factor, the speed does not like, if there is no air, so there is no loss of energy or there is no work against the air resistance. As there is no work against the air, so the speed at which it is moving, that does not change or that remain constant. Otherwise, if the speed decreases, the range will also decrease, but speed remain constant. That's why the range also will be like higher range, or there's no deceleration. So this was question 20.